Hey guys, this video is for 6.4 lesson, Solving Radical Equations, Day 1. We are going to be spending 2 days in this section of the book. So we have done something similar to this before. We have taken equations that had powers in them, like x to the second power, x to the fifth power, and we've taken a root of that same power. We've matched the power to the root to solve our equation. Now we're just doing the opposite. We're going to start with something that's taken to a root, a square root, a cube root, a fourth root, a fifth root, etc. And we're going to use powers to cancel that out and then continue solving the equation. So one important thing to note that I've written here is that when you're solving equations with radicals, you have to always check your answer by substituting back into the original equation. We can come up with kind of false answers, or what we call extraneous solutions, as a result of squaring both sides, because some things that were negative become positive when you square something, and so it can introduce numbers that look like they're solutions, but they don't actually make the original equation true. And so we've got to be on the lookout for that. So let's take a look at some examples. And in these examples, we are going to solve and then check our answers. Checking is as important as solving, because if you don't check it and it's a incorrect answer, it's one of those extraneous solutions, then your whole problem is incorrect. So example number 1, we're going to have 2 times the square root of x plus 1, and that equals 4. So we're going to approach solving this just like we would any algebra equation. The thing that we want to do first here is to isolate the radical, the stuff under the square root in this case. I'm going to switch to a different color so that it's clear what was the original problem in pink, and now my solution is going to be in blue. So if we wanted to get rid of anything that's not under the radical on the left-hand side, we would need to divide both sides by 2 so that those 2's canceled. And I have x plus 1 left on this side, and I have 2 left on the right side. Now, this is a square root. How do I know it's a square root? It doesn't have any little floating number out to the front of the root. But I'm going to go ahead and add that number here just for emphasis. So I'm putting a 2 there to emphasize that we are taking the second root, or the square root, of x plus 1. So in order to undo that, similar to addition and subtraction undoing each other, multiplying and dividing undoing each other, roots and powers undo each other. So I'm going to take this to the second power. I'm going to square it. But if I do that to one side, I have to do it to the other side, so the 2 also gets squared. So again, because I've had a second root and a second power, those cancel. And so I'm just left with x plus 1 on this side, and 2 squared is 4. Now we just continue solving using our algebra skills. The next thing we would do is just subtract 1 from both sides to get x by itself. And so x equals 3. So again, that's our potential solution, but we have to check it to make sure that it really is a true solution. So I'm going to change colors again to indicate that this is something different. Now we're checking. And we're just going to plug back into our original equation with what we know x to be, or what we think x is. So I'm going to say 2 times the square root of 3 plus 1 is equal to 4. And we just continue simplifying this until we get one side equal or not equal to the other side. So 2 square root of 4 equal to 4, or 2 times 2 is equal to 4. And yes, this is a true statement. 4 is equal to 4, so we can check that and then box our answer. Do not box an answer that's an extraneous solution. So don't go boxing everything until you know that it truly is a solution. All right, let's look at another example here. So example 2. This time let's do a third root instead of a square root. So how do I know it's a third root? It's going to have a little 3 floating out there as my index. 2x minus 9 under the cubed root minus 1 is equal to 2. So again, the first thing I want to do is isolate just everything that's under the radical symbol. So I want to get rid of that 1. And the way I would get rid of the 1 is just by adding 1 to both sides. This is an important step. Don't skip this step. You can do it other ways, but your math becomes a lot more complicated. You're going to be having to distribute a lot of things extra if you don't get rid of everything on the side of the radical first, if you can. All right, so we are left with the third root of 2x minus 9, and that's going to be equal to 3. And then let's continue. We have a third root, so we need a third power to cancel that out. So the 3's cancel, the root and the power, and I'm left with 2x minus 9 is equal to 27 when you take 3 to the third power. Now we just continue solving using our algebra skills. We add 9 to both sides, giving us 2x is equal to 36. And dividing by 2, we get x is equal to 18. So again, this is our potential or apparent solution, but we have to check our work and see if it is actually a true solution or if it's extraneous. So I'm going to plug 18 back into my very original equation. All right, so my original equation was in pink up there. Third root of 2 times 18 minus 9, so that's all under the root, minus 1 equals 2. So again, just simplifying. And if you don't need to take this many steps, if you are putting this into your calculator, that's fine. Just be careful that you get everything in the right place if you're doing this in a calculator. That's a 36 minus 9 is minus 1 is equal to 2. Or the cubed root of 27 minus 1 is equal to 2. And that leads me to 3 minus 1 equals 2 and 2 equals 2. So that's a true statement, which means that our answer is a true answer. It's not extraneous. All right, so in these last couple problems, what we've done is we've had our root and maybe some extras on one side, and we've had just a constant on the other side. Now we're going to look at an example where we actually have an x on both sides, one under a root and one out of the root. And so that changes things up just slightly. So let's take a look at that. So this would be kind of a step up in difficulty level. So x plus 1 is equal to the square root of 7x plus 15. All right, so the 7x plus 15 under the radical is already isolated. There's nothing added or subtracted on the back end. There's nothing being multiplied or divided out in front. So we're ready to just go ahead and get rid of the root by taking the power. So again, this is a square root. We could put the little 2 there if we want to remind us of that. So we are going to square it or take the second power in order to get rid of that. Whatever we do to one side, we have to do to the other side. All right, so you need to be careful here. X plus 1 in parentheses to the second power means this. It means x plus 1 times x plus 1. So we're going to have to do some polynomial multiplication just like we did in the last chapter. You could use box method for this, or you could use distribution, either one. All right, and then on the right side, the second power and second root cancel, and we have 7x plus 15. Okay, so let's do this multiplication. I'm just going to distribute. So I'm going to distribute the x to both pieces, and I'm going to distribute the 1 to both pieces. So let's just go ahead and do that simple binomial multiplying. X squared plus x takes care of the green, and then plus x plus 1 takes care of the orange. And let's clean this up a little bit. Let's combine our like terms. So x squared plus 2x plus 1 is equal to 7x plus 15. Now I'm noticing that I have an x squared here, which means that I'm going to need to use my quadratic form or an x puzzle to solve this. And so in order to do that, I need everything on one side of the equation, preferably with just a plain old x squared as my leading term, if possible. And then I just want a 0 on the other side. So let's do that. Let's subtract 7x and subtract 15 from both sides. This leaves me with x squared minus 5x minus 14 is equal to 0 because these cancel. And now I can do a simple x puzzle. I need factors of negative 14 that add to be negative 5, and that would be negative 7 and 2. So I can rewrite this in factored form as x minus 7 and x plus 2 is equal to 0. And then setting each piece equal to 0, x minus 7 equals 0, we would add 7 to both sides, giving me x equals 7. And then x plus 2 equals 0, we would subtract 2 from both sides, leaving me with x equals negative 2. So again, these are potential solutions or apparent solutions. We need to see if either of these is extraneous. All right, so let's check by plugging into our original equation, putting in a 7 everywhere we see x. So I'm going to have 7 plus 1 is equal to the square root of 7 times 7 plus 15. 8 is equal to the square root of 49 plus 15, which is 64. And the square root of 64 is 8, so this is good. We can box x equals 7 as an answer. But let's check our other one. So let's check with x equals negative 2. So we have negative 2 plus 1 is equal to 7 times negative 2 plus 15. And let's continue simplifying. We have negative 1 is equal to the square root of negative 14 plus 15, which is going to simplify to square root of 1. And the square root of 1 is 1. So negative 1 is not equal to 1. This is no good. So that means that x equals negative 2 has to be crossed out. Please be sure that you don't skip the step of crossing out extraneous solutions. Okay? You want to make it very clear that you are understanding what solution is a true solution and what one is extraneous if there is one. So be sure you don't skip that step. All right, so this next one is what I'd call kind of a level 3 problem. This number 3 was kind of a level 2 problem. We kicked it up a notch by having x's on both sides. Now for this one, we're going to kick it up the final notch and have roots on both sides. So we're going to say x plus 2 under a square root sign plus 1 is equal to the square root of 3 minus x. Okay, so that plus 1 is a little pesky because right now I cannot isolate a radical on both sides. I have the 3 minus x under a radical on the right side that's isolated, but on the left side I have the x minus 2 radical, but I have that plus 1. Well, I could move the plus 1 to the other side, but then the right side wouldn't have it. So we are just going to have to deal with the fact that we have something besides a radical on the side. So we're just going to start by squaring to get rid of my second roots. Okay, so if we have something with more than one term that we are squaring, that means we got to do kind of like we did on the last problem and expand it. So we have the square root of x plus 2 plus 1, and then we're multiplying it by itself. Square root of x plus 2 plus 1. On this side, our squared and our square root cancel, and we just have 3 minus x. So I'm not going to deal with that side for a moment. I'm going to deal just with the left side and clean it up. So I'm going to distribute, or you could also use your box method if you like that, the method that was shown on Delta Math when we were practicing that. So I'm going to have square root of x plus 2 squared plus square root of x plus 2. That takes care of the green. If I keep going, I have another square root of x plus 2, and then finally plus 1. And that's still equal to my 3 minus x. All right, if I have the square root of x plus 2 and I'm squaring it, those will cancel now. So I have x plus 2. I can combine these two middle terms and say that I have 2 square roots of x plus 2, still plus 1. And now let's combine like terms. So I don't have anything that I can combine with x, but I can combine the 2 and the 1 to say 3 plus 2 times the square root of x plus 2. All right, now we have something where we have only a square root on one side. So let's get everything else to the right-hand side and isolate that radical. So anytime that you see a radical on both sides, you're going to have to expect that you're going to have to do the process twice. You're going to have to take a power to get rid of a root 2 different times if you have it on both sides. So I'm going to start by subtracting x and subtracting 3 from both sides. So those cancel, and I'm left with 2 times the square root of x plus 2. On this other side, I have a 3 and a negative 3, so those cancel, and then I have a negative x and a negative x, so negative 2x. All right, my root is still not quite isolated because there's a 2 out in front of it, so I'm going to divide by 2 to get rid of that. And now finally I have my root isolated, and I have a negative x over here on this side. Same process we did before. Here's our second time around. I'm going to square both sides in order to get rid of the square root. So the 2's cancel, the root and the power, leaving me with x plus 2. And then on this side I get an x squared. When I take negative x and square it, the 2 negatives cancel to become a positive. All right, I have an x squared on the right-hand side. This is leading me to think I'm going to need to use quadratic form to solve this, or also known as x puzzles. So let's get everything over to the side where the x squared is by subtracting. Everything cancels on that side, leaving me with x squared minus x minus 2. Simple little x puzzle will do the trick here. So I look for factors of negative 2 that add to be negative 1, which would be negative 2 and positive 1. So I can rewrite this in factored form. X minus 2 and x plus 1 equals 0. And then setting each piece equal to 0, I'm going to get x equals 2 and x equals negative 1. These are potential or apparent solutions, but again, our final step is always to check and see. So let's check the x equals 2 first. So I'm going to have the square root of 2 plus 2 plus 1 is equal to the square root of 3 minus 2. Just working the math here. 2 plus 2 is 4. Square root of that is 2. And then 3 minus 2 is 1, and the square root of 1 is 1. So my final answer is 3 equals 1, which is obviously not true. So this x equals 2 is not a solution, and you want to cross it out. Let's check x equals negative 1. So we will have square root of negative 1 plus 2 plus 1 is equal to the square root of 3 minus a negative 1. All right, so square root of 1 plus 1 is equal to the square root of 4. 1 plus 1 equals 2, and that is true. 2 is equal to 2. So we're good there, and we can box this solution. All right, guys, that's it for this lesson. We will continue with day 2 in the next lesson. Thanks.